This is geometry 9.4. We're talking about specific parts of a circle. We have chord, tangent, secant, and point of tangency. Here's a bit of a diagram that goes through and talks about the different parts. So the first one we're going to talk about is a chord. So here's an example of a chord. It's a segment that's touching the circle at 2 points. So I'll color code the chord. It's a segment touching a circle at 2 points. You could say that the endpoints are on the circle. That'd be another way to phrase that. So we have our circle with our center point, and a chord is going to touch a circle, have those endpoints on the circle in 2 different spots. It does not extend outside the circle. It does not have to contain the center of the circle, just to be a chord. Next, we can look at tangent. The tangent would be right there. Color code that. A tangent might be a segment, might be a line, or it might be a ray. So a segment, a line, or a ray on the exterior of the circle that touches only once. Touches a circle only once. So see how this comes through on the outside of the circle, touches the circle, and extends through in this case. So we have our circle with our center point, and our tangent shoots right through there. Next, we have a secant. Secant is very similar to a tangent because it's on the outside of the shape, but then it comes to the inside of the shape and can extend through. So we could color code. So we have a secant, a line, that contains the chord of a circle. So notice when the secant comes through the circle, the part that's inside the circle would be considered the chord. So a secant contains a chord. It touches a circle in 2 spots. Right, it goes all the way through it. So there's our circle, and a chord is going to, not a chord would be up here, but a secant is going to go through the circle. And then point of tangency. The point of tangency would be right here at that location. Point of tangency is where the tangent line touches the circle. The point where the tangent line touches the circle. So if we have a circle and a tangent, that's going to touch right at that location, that one spot that the tangent line touches. So this is your point of tangency. And we could color code that too, I imagine. You also, in the past, have been familiar with a radius. A radius goes from the center to the edge. And then a diameter. A diameter is two different radii going in opposite directions. A diameter is a chord that contains the center. It's a special chord because it contains the center. You already know about diameter. You already know about radius. Now we've picked up 4 more vocab words. Chord, tangent, secant, and point of tangency. So we come down here to this figure and we look to see in terms of matching. BC, segment BC, which one does it match up with here? We're looking for words like radius, chord, diameter, secant, or tangent. So BC is going to be the radius. It goes from the center of the circle out to the edge of the circle. That's a segment. Line EA. E to A looks like that would go right inside and through and outside the circle. So that's going to be called a secant. DE. Looking at the letters DE, and we connect those and go back and forth. That's on the outside of the circle, never going inside the circle, but it does touch the circle at exactly one point. So that would be a tangent. Segment FA. This is a segment, no arrows on it. F to A, that's going to be a chord. And then AB is just like a chord. It touches the circle in 2 spots, and it's a segment. But it contains the center. So this chord is actually called a diameter. We flip over. And we do it again. Now we're specifically matching. We have D. So we're going to find where D is inside our picture. D is this one spot standing out here all by itself. It's a single point. So that would be a point of tangency. Number 2. This looks like line FH. F to H, but it's a line, so it goes on forever past it in both directions. Now, this is kind of a new word. Notice that we have a circle on one side of this line, and we have a circle on the other side of this line. So actually, this line is in between these two circles. So that's going to be called an internal. A common, because there's two circles, internal tangent. CD. You got to find the C and the D, and what's that going to be called? There's our radius. Next we have AB. It's a segment, A to B, touching the circle in two spots. There's not arrows on it, so we're not talking about the parts on the outside. We're just going from A to B. So that is a chord. Next we look for the letter C. C is on the inside of the circle, right in the middle. That's called a center. AD goes from one side to the other side of a circle, and it contains the center. A chord that contains the center is called a diameter. A line, AB, it would be our chord that extends forever in both directions because it has arrows on it. That's going to be our secant. And then the final one, DE. DE has the circles on the same side of the line. The line is touching each circle at exactly one point. So that is called a common external tangent, because it's on the exterior of those two circles. It's not in between the two circles like this tangent was. This one was between them, the internal. This is considered an external because it's on the outside of both circles. So talking about tangent, this type of tangent is not your opposite over adjacent type of tangent. It's not the trigonometry type of a tangent the way we're using it. In a plane, a line is tangent to a circle if and only if the line is perpendicular. So every tangent line is going to be perpendicular to the radius at that point of tangency. So if you notice, here we had this external tangent, and we drew the radius in here, and it has the box because it's 90 degrees to that tangent line. Or the internal tangent is going to be perpendicular to a different radius. From the center to the point of tangency is going to be a right angle. Tangent line and that radius. So when we come down here, we're trying to determine, do we have a tangent? So to figure out if we do have a tangent, okay, let's first do letter B. B is a little bit more straightforward. Okay, they give us all the information we need. So our larger number is 26, and we compare that with the 10 and the 24. So we're doing our Pythagorean theorem just like we've done in the past. So we get 676. and we're comparing, that's what that symbol means. Compare 100 and 576. So yes, we see that 676 is going to equal 676. Therefore, ST is a tangent because it formed a right angle. The longest side squared equals the sum of the square of the other two sides. Now, when we come over here to letter A, what makes letter A trickier? If 12 is the radius from R to S, 16 is the length from S to T, 7 is the distance from T to the edge of the circle. 7 is not the total length. 7 is just to the edge of the circle. So what is the total length of TR? Well, every radius is exactly the same. So this radius is 12, this radius is going to be 12. So this is going to be 12 plus the 7, which is the 19. And we compare that with the 12 and the 16. And we get 361, 144, and 256. That gives us 361 that does not equal 400. So ST is not a tangent. This did not form a right angle. The radius is not perpendicular to the tangent line. And then the last one that we have down here, we'll do here with the smaller numbers. You do need to see this. This is the tangent. This is the radius. So we have R plus 9. That's the whole trick of the whole problem is right there. What do we do with R plus 9? That's the hypotenuse. And that is supposed to equal R squared plus 15 squared. We're just doing Pythagorean theorem. When you square parentheses, you cannot distribute this in. You have to write it 2 times. R plus 9 and R plus 9. Now back in algebra class, you learned when you multiply binomials, you have to do the front 2 numbers, which is R squared, the outer numbers, which would be 9R, these 2 inners, which would be another 9R, and then the outside, or the last, which would be 81. That's called FOIL. Now you're down to just a regular algebra problem where we have to collect our like terms. Since we go on opposite sides of the equal sign, we subtract the R squared, we subtract the 81, we get 144. This makes 18R, and when we divide by 18, we get R equals 8. 8 on page 8. So the radius would have to be 8, and we did that with the Pythagorean theorem. You have to write your hypotenuse twice. And then our last one, the numbers are a little bit bigger. We get R plus 49, and we square that. We know this is a tangent. So we can say equals R squared plus 77 squared. What we've talked about, this is called a binomial. When you square it, you have to write this parenthesis twice. Then we do what's called FOIL. and you multiply the front to give you r squared. You multiply the outer to give you 49r, the inner to give you 49r, and the last to give you 49 squared, which is 2,401. And 77 squared. So just like we did in the previous problem, we start to collect like terms. Here we get 98r because they're on the same side of the equal sign. Here they're on opposite sides of the equal sign, so we're going to subtract those opposite sides of the equal sign. Divide by 98. And we get 36. So our radius in this case would have to be 36 for this to be a right triangle.